Hello, everyone. This is our presentation on machine learning versus logistic regression methods on predicting pathological features for microsatellite instability in colorectal cancer. My name is Kevin Tseng, and my partner is Jae-Young Kim. So in colorectal cancer is the third most common cancer diagnosed in the US, and 15% of these occurrences can be categorized by having high levels of microsatellite instability, MSI-H or MSI-High. It is a phenomenon when the microsatellite, these short repeated sequence of nucleotides, getting mutated and is different from what it was inherited. This happens when the mismatch repair machinery did not repair the DNA replication errors correctly. So in the 2009 Greenson paper, which is all the data and all the idea originate from this project, and they studied these colorectal cancer samples under H&E slides under the microscope, and they're looking at these histological features. And I'm not going to pretend I'm an expert in pathology, but these are just examples for you to look at these images. So from these images, Dr. Greenson was able to come up with this list of features that explains or that represents these samples. I'm not going to go over everything, but some key ones to look out for is dirty necrosis, tumor necrosis, and then tumor infiltrating lymphocytes, which are white blood cells that kind of like infiltrated into the tumor, which means the body is fighting the cancer, and also different differentiation grades for the tumor.
Okay, hello, I'm Jae-Young Kim, and I'm going to explain what we have done. So first of all, in 2009, Greenson model showed 0.85 ROC AUC score with using logistic regression model. But they made another model in 2020 with by using new data. Even though they made ridge regression model, they had worse score, 0.749 ROC AUC score. So in this research, what we have done is, first of all, making the performance of the model better. And secondly, we wanted to figure out which feature is important in predicting MSI-H. So for the evaluation metric, we used ROC AUC score for two reasons. So first of all, in the previous research, they used ROC AUC score. And so to compare with the previous research, we used ROC AUC score. And secondly, the data is very imbalanced. So in our research, the data, there were about 1,900 rows, but there were only 300 MSI-H1 patients. So in the imbalanced data, accuracy doesn't show many things. So we just used our AUC score to calculate the performance. So here are some models we used. So we used linear models to reproduce the previous researchers' model. And secondly, we used tree models because we thought it is very effective in classification tasks. And thirdly, we used SVM model, and we used KNN and NIBase model and ANN, artificial neural network model. So this is our research result. So it showed that overall three models showed pretty good result, and knife-based classifier also showed great performance. So in the right side, you can see the ROC AUC score and the curve.
As for feature importance, we plotted out 10 out of the 12 models because for ANN and KNN, they do not have an intrinsic way of looking at feature importance. And so we looked at looking at these graphs, we see that consistently TILs is the top ranked feature. And coming close in second is NoNecrosis and moderate differentiation, just based on looking at these graphs. Next. And so in conclusion, we agree with 2009's results and saying that TILs and NoNecrosis are the crucial predictors of MSI-H, but we're adding moderate differentiation as another feature based on our results. And throughout these 12 models, random forest, LightGBM, and naive-based classifier shows the best performance to predict MSI-H. And then clinicians can now use our results and better classify MSI-H in their samples. So this is the end of our presentation. Thank you.
Thank you.